moment of a force. So we want to know what do we mean by moment of a force. And this moment of a force depends on which two factors? We are going to look at factors that moment of a force depends on. Now when we talk of moment of a force, it simply refers to the turning effect of a force. Moment of a force simply refers to the turning effect of a force. So when we simply talk of moment, we simply talk of the turning effect of a force. And in our day-to-day lives, we encounter some activities that involve the turning effect of a force. And we can list down a few of them. So we can look at examples of activities in which force will produce a turning effect. Examples of activities in which force produces a turning effect. And one of the examples that I had already mentioned is when you are opening and closing a door. Opening and closing a door will lead to turning effect of that door. So when you apply force to a door, when it is closed and you are opening it, or when it is open and you are closing it, when you apply force, then it will bring out what we are calling the turning effect. So one of the examples of such activities we had also mentioned about when you are opening a tap, opening a water tap, or it can be any tap. It can be a gas tap. So when you are opening a tap, you are also applying force on it, and as a result, it brings a turning effect. Again, when you are balancing on a seesaw, when we talk of a seesaw, this is what we mean. In a seesaw, we have this point which is fixed. We call it the pivot, or what we call the fulcrum. So when we have one person on this side and another one on the other side, we see that when you try to balance on the seesaw, it is bringing about what we are calling the turning effect. Because when this individual is on this end, he or she will apply some weight at this part, which will lead to the turning of the seesaw. So we can also talk of balancing on a seesaw. We can also talk of tightening or loosening a nut using a spanner. Tightening or loosening a nut using a spanner. That is another activity that will where force will produce a turning effect. We can also talk of steering a car. Steering, it's also bringing about a turning effect. Steering. We can also talk of cycling. Will also bring about the turning effect. So you can add to that list. So those are some of the examples of activities where force produces a turning effect. It is very examinable. You can be asked to give an example of an activity in which force will produce a turning effect. So we've said opening and closing a door, opening a tap, balancing on a seesaw, tightening or loosening a nut using a spanner, steering a car, cycling. Those are some of the examples where a turning effect will be the result. So those are the activities, and now I'd like us to consider the following. Consider this. Now, if we take this sign to be the fixed sign, let's say someone is holding this sign, this is our fixed end. And then at this point here, we apply some force. We apply some force at this end here. We can apply the force by maybe hanging a mass, and this mass will exert some weight, and therefore we'll have some force on this end. Now, so we have our fixed end here. We have the force being applied at this point. Then we have the distance from this fixed end to the force, where the force is. We can call it our perpendicular distance. It is a perpendicular distance from this point of support, which is the fixed end, to this we refer to as the line of action. As you can see, where the force is acting. So this one is our perpendicular distance. Perpendicular distance. Now, when we have more force here, when we apply more force, this bar here, this is our bar, will turn more. The more the force being applied, the more the turning. Just like, for example, when you want to open a door and you apply some very little force compared to another time where you apply a lot of force, when will the turning be more? Or when will the door open more? It is when you apply more force. And therefore we can see that one of the factors in which moment of a force will depend on is the amount of force. We call it the size of force being applied. The more the force, the more the turning, and vice versa. Again, we also consider this distance here. So, and that's why you'll find that in our doors, you find that the hinges are far away from where you apply the force, where you open and close the door. The hinges are far away. So the more the distance here, the more the turning also. So if the force is being applied, let's say at this point here, let's say here we have a force 1, and here we have a force F. This force F will produce a more turning than force F1. And therefore we can say that the more the distance, the more the turning. And that's why it's advisable when you are using a spanner, it's easier to use one which has a longer handle than the one which has a shorter one. If I take an example of this pen here, if I apply force, let's say this is my fixed end, which is now my pivot. If I apply force on this end here, compared to applying force at a point near the fixed point here, it means that when I apply force at the end here, it will bring out about more turning than when I apply force at this point. So we can say that moment of a force about a point depends on moment of a force about a point depends on, remember we said moment of a force is the turning effect of a force. So it will depend on, number 1, the magnitude. Another name for magnitude is size, magnitude of force, the force being applied. The more the force, the more the turning effect. Number 2, the distance. In this case, we are talking of the perpendicular distance. So the turning effect of a force, what we are calling the moment of a force, about a point. In our case, we are talking of this, about this point, which is fixed, the fixed end, will depend on, 1, the magnitude or the size of force. And we are saying the more the force being applied, the more the turning effect. And the lesser the force being applied, the lesser the turning effect on this bar. Then we are saying the other factor is the perpendicular distance from the point of support to the line of action. And we are saying that the more the distance from the point of to the line of action, the more the distance, the more the turning effect. And that's why we are saying the hinges of a door are always far away from where the opening is done. When you want to open a door, you can't go to open near the hinges. You need to open some distance away from the hinges so as to increase that distance from the fixed point to where the force is being applied, hence increasing the turning effect. So those are the two factors in which moment of a force about a point will depend on.